So far we've simplified radicals and we've added and subtracted radicals. Today we're going to multiply and divide radicals. Take a moment, pause the video, copy the steps, and then come back and we'll go over them. Okay, now that you have the steps copied, basically what they're saying is you have to have the same index, meaning you can only multiply and divide square roots by square roots, cube roots by cube roots. Do you see what I mean? So once you have the like indexes, then in multiplying and dividing, you multiply and divide the coefficients, which are the guys on the outside. You multiply and divide the radicands, which are the guys on the inside, and you simplify. So again, in this case, you're not going to need like radicals, so it's going to be a lot easier. So let's move on to number 7. In number 7, 6 radical 5 times 2 radical 15 is going to give me 6 times 2 is 12. And radical 5 times radical 15 is radical 75. All right, let's see if we can simplify 75. Bring down the 12. 75 is 25 times 3. Square root of 25 is 5. When 5 meets this 12, we get 60 radical 3. And there's my answer. That's how easy this is. Let's go to number 8. It's a radical. So it's 7 radical 3 squared, which is 7 radical 3 times 7 radical 3. They're both square roots, so I can multiply them. Multiply the outside guys and the inside guys. So 7 times 7 is 49. 3 times 3 is the square root of 9. Square root of 9 is 3. When 3 meets 49, it multiplies. You get 147. There's nothing left under the radical, so your answer is just 147. Pretty easy, huh? Let's move on. Number 9. You're multiplying one thing times many. First of all, I have a set of parentheses, so I have to see if I can perform the indicated operation because of PEMDAS. And I can't simplify radical 2, and I can't simplify radical 7, so I can't add them, so I can't do anything that's inside the parentheses. So I have left is multiplication. So in this case, when you multiply one thing times many, it's distributive property. So 2 radical 5 times 3 radical 2 is going to be 6 radical 10 plus 2 radical 5 times 1 radical 7, because remember there isn't a number in front of the radical, it's understood to be a 1, will give me 2 radical 35. Can you simplify radical 10? No. Can you simplify radical 35? No. So 6 radical 10 plus 2 radical 35 is your answer. Let's move on to number 10. They're both square roots, so I can multiply them. All right, it's a binomial times a binomial, so I'm going to do FOIL. But look at this one closely. Isn't this dots? So really when it's dots, I just truly have to do first and last because outer and inner are going to cancel out. So first, 4 times 4 is 16. Last, positive radical 6 times a negative radical 6 is going to be a negative radical 36. Square root of 36 is 6, so now I have 16 minus 6, which is plain old 10. How easy was that? Let's go on to some more examples. Number 11, 5 minus radical 2 squared means 5 minus radical 2 times 5 minus radical 2. Again, it's a binomial times a binomial, so I'm going to have to do FOIL. First, outer, inner, last, combined like terms. And if I look closely, it's not dots, so I have to do all of FOIL. All right, so here we go. 5 times 5 is 25. Outer, 5 times a negative radical 2 is going to be a negative 5 radical 2. Inner, negative radical 2 times 5 is a negative 5 radical 2. Outer, last, negative radical 2 times negative radical 2 is a positive radical 4. Let's go over that one more time. Remember, when there isn't a number in front of the radical, it's understood to be a 1, and you multiply the outside guys and the inside guys. So if you take a look at the outer, 5 times a negative radical 2, it's 5 times a negative 1 is a negative 5, and then you bring over the radical 2. And when you take a look at last, a negative times a negative is a positive. 1 times 1 is 1, which you don't need. And the inside's 2 times 2 is 4. Okay, let's combine like terms, which are the two guys in the middle. They do not cancel out. Take your calculator and plug in negative 5 minus 5 and tell me what you got. You're right. So you have 25 minus 10 radical 2 plus square root of 4 is 2. So it's just plus 2 because there's no more radical. Let's neaten this up. 27 minus 10 radical 2. I can't simplify radical 2 anymore, so I can't subtract them. So I'm done. Let's take a look at number 12. Number 12 shows me that I'm have subtraction and then division, and I have parentheses, so I have to try to subtract first. So in order to subtract, if you recall, you have to have like radicals, and in this case I don't, so I'm going to try to find them. So I need the largest perfect square root that'll go into 128. Remember, back up your list and find the biggest one. Hopefully you said 64 times 2. Minus the biggest perfect square root that'll go into 72. You're right, 36 times 2. Divided by the biggest perfect square root that'll go into 8. You're right, 4 times 2. All right, let's see what I have here. Square root of 64 is 8, so I have 8 radical 2 minus square root of 36 is 6. 6 radical 2 divided by square root of 4 is 2, so I have 2 radical 2. 8 radical 2 divided by, subtract 6 radical 2 gives me 2 radical 2's. Divided by 2 radical 2's. When you divide the same thing by something by itself, it's always going to be 1. If it's hard to see, maybe you might want to write it this way to take a look at it. And 2 divided by 2 is 1, and radical 2 divided by radical 2 is 1, and 1 times 1 is also 1. No matter how you look at it, it's 1. So let's move on. Last problem for today. There are no parentheses, so I do not have to do the addition first. If I'm doing PEMDAS, it says parentheses, exponent, and then it's multiplication and division. I have division, but I'm dividing many things by something, and when that happens, I'm going to need to actually divide everybody on the top by the guy on the bottom. So I have 20 radical 27 divided by 4 radical 3 plus 8 radical 18 divided by 4 radical 3. Let's see what I have. 20 divided by 4 is 5. Radical 27 divided by 3 is radical 9. Plus 8 divided by 4 is 2. Radical 18 divided by 3 is radical 6. I can simplify the square root of 9 because it's a perfect square root. It's 3, and 3 times 5 then is 15 plus 2 radical 6. I can't add any further, so that's my answer. So today we learned how to multiply and divide, which seemed a lot easier than adding and subtracting, but we also threw some twists in there with FOIL and distributive property and dividing by more than one thing. So you may want to take a look at this one more time before you put it to rest for this evening. I'll see you in class tomorrow.